Hola a todos, buenas tardes.
Hello, good afternoon to you all. Well, this talk is about something that I've been always obsessed by, or rather since Skype started. That was back in 2003. Of course, I hope I don't have to tell you what Skype is about, but this is a slide as a reminder slide. Well, Skype stopped being independent back in 2011. It was bought by Microsoft, and then second is that Skype is not only used for personal communication, as you all know, but Skype is widely used as at the workplace. It's not a corporate tool, however, it has a strong impact in terms of productivity and performance of workers. So the aim of this talk is kind of to expose Skype as it is nowadays. Why was I so impressed about Skype? Why couldn't I see the same appeal in other type of voice IP communication? And for me, what was the strongest point about it was privacy. Privacy was just a consequence of the global architecture of Skype service. From my viewpoint, there were two key points explaining that level of privacy. The first one being that the Skype protocol used or combined client-server communication or peer-to-peer communication through a key element of the architecture, which are the supernodes. We'll discuss that later on. And the second determining factor is that Skype used to use a proprietary encryption mechanism. So whenever someone the formal response of Skype was when someone requested something, Skype said, well, we cannot really do that because we have proprietary mechanisms that that does not allow us to do any to provide that information. The thing is, well, Skype is a protocol that had embedded mechanisms for evasion. They were very clever, and that was combined with self-recovery. So if you wanted to reduce or to restrict the width band, you couldn't do it, but Skype then reconnected itself, even if you could not restrict the width of the band. Therefore, I would try to analyze whether those two factors that made Skype different, I would like to see whether they're still on in terms of security and in terms of privacy. Supernodes. Whenever a Skype client logged on, tried to do it through an IP point address, and these were supernodes. And the Skype client established communication, and then the peer-to-peer communications were established. But something wonderful about supernodes is that anyone, without knowing it, could become a supernode. Any Skype user, any system run by the Skype user could become a supernode, of course, provided it complied or fulfilled the number of requirements, such as, I don't know, certain bandwidth, etc. So therefore, you could allow access to Skype to some users, and that user could detect that other users had also access to it, and therefore it accessed the Skype service through one of these supernodes. So at a given point in time, you could just take a look and could see that there were many Skype users that were behaving as supernodes, and each of them could handle around 800 users per each supernodes. One of the things that changed after Microsoft bought Skype is that supernode architecture was maintained. However, individual users or Skype clients could not become supernodes automatically. So that is to say, being upgraded to a supernode, nowadays it's only possible from servers, for instance, Linux, that are hosted in data centers of Microsoft. The analysis that I will show you later on I did not include it because of questions of brevity, and the analysis that I did confirms that. That is to say, for hours, Skype clients, when it comes to establishing some communication protocols, in the past used to do it through supernodes. Now all the supernodes are hosted in, or IP addresses are hosted in Microsoft data centers. Well, actually, the good thing is that these data centers are more powerful than in the past. Skype encryption. I've always been fascinated by that. In the past, there was no documentation. Existing documentation was kind of obsolete. So, Skype architecture has been changed in terms of supernodes, and then I asked myself, well, what happened with encryption? Did they change that as well? Have they made it more standard encryption? Well, amongst many other good things, when you work in this type of technology companies, you have access to very interesting gadgets. One of those gadgets is the gadget that I will use if I may have your permission. It is one that will let me see whether Skype is using the proprietary node or not. And for that, I have a PC, Skype. I hope you can see well the name of the version. Earlier versions than that behave dramatically different in terms of encryption, but this version or higher versions work and I will capture in data through a security analytics tool. Well, because this is thought for big data, for, I don't know, 10 gigabytes links, it allows you to cross-index packages and to gather that information from headers, level 7, to keep up another structure for data, detecting security breaches, and that is the main purpose of it. But it is also good to play around with it now and again. Yes, I know that you cannot read it from your seats. Well, if we zoom, well, this is for you to see that it does many cool things. The cool things that we are interested in are SSLs. Well, some of them are recognized as Skype, others as unknown, others from Facebook, then DNS from Microsoft Network, Messenger, Microsoft clients. Interesting. We have SSLs in Skype. To confirm that, we are going to take a look at the names to confirm that that belongs to Skype. I really want to see those names on that SSL traffic. Some of these names are actually generic. Well, information is duplicated here, is doubled. Let me see if I can use the mouse here. So some names refer directly to Skype, others to Facebook, other ones to Skype, to other sites. MessengerLive.com. This is not a surprise, since Microsoft short ago announced that from Skype you can get in contact with link users. Well, it asks you whether you want to log in with your Skype user or with your Hotmail user. So, what are the important or interesting findings? Whenever I analyze the names of the web servers, after confirming that all these belongs to Skype, I start to see a number of servers that do not really make any sense from the viewpoint of Skype. Then I classify them, I establish categories, and then I see more outstanding activity related to sites that do AdWords or advertising, and then sites that gather users' analytics, tell us, yes, to measure user's activity. Well, after that I said, okay, Skype encryption looks that has shifted from the proprietary encryption system to SSL. Skype instant messaging is using the Microsoft network. We knew that. Well, I mean the Messenger, Microsoft Messenger sites. And then these sites for analytics and for ads could take us to think that Skype users are kind of becoming products, and that is detrimental to our privacy as users. And because I'm obsessed with privacy, I decided to remove the codes of Skype. Well, because we have SSLs, is my Skype user vulnerable to an SSL? And see how far we can get in our analysis. And as I'm telling you, at work I have access to a number of good toys, and I decided to include one more toy in my equation. So security analytics remains in the same place. I've changed the previous switch by this device, and this device intercepts SSL traffic. It does that interception both when I have the private key of the digital certificate of the service, and also when I don't have that certificate. Therefore, one of the elements that I need for this is an FBA, that is to say a CA intermediate certificate. Well, in order to see how easy it was to make an attack, because it is difficult to steal a public CA, I said, okay, I'm going to produce a private one. So I created with my PKA, I created an intermediate CA, I loaded it as reliable CA, I loaded it in my PC, in the certificate store of my operative system. And then I took this very same one and I loaded it as signature CA on the SSL interceptor. SSL interceptor will catch the traffic with digital certificate, will abstract all the information, common name, etc., will make a note of all the CAs that have generated the certificates, and then will use those data, but signed with that CA, and of course, whilst keeping the whole chain, the whole existing chain. Whatever it is intercepted is sent out to me through an interface that captures packages. Well, I chose that one, but any other one could also be okay. So I log on Skype and then I start to capture data, and it works. You can also do a man in the middle. So I stopped. I no longer see common names. That is empty. Then now I can see different HTTP servers. So Windows Live, Facebook, Hotmail, Azure, which is the cloud service of Microsoft. Well, you can do that. So therefore, Skype clients are partially using SSL encryption and doesn't say to the user that he's doing so, and you cannot really see the certificates that are running, because I cannot really see the lock. I don't see the lock icon that I often get with certificates, and at the same time is using the certificate store of the OS, because otherwise I would not have been able to make that interception. Therefore, this tells me that, yes, I can do a mal in the middle. And then it also tells me that it is more vulnerable than those applications that come with their embedded certificate store. And then doing mal in the middle is not difficult, provided I know how to insert the CA in the list of reliable CA certificates. And the user would never ever know that I am opening that communication. Now that I know that I can do it, I want to analyze the information that I capture. And what do I capture? Well, whenever I log in, I can put this. So there is something here that I did not decipher, which is the user identification code. That could be the password of the user session that is encrypted, considering that we have the user's name. This is the user's name used by the user, in this case, for this proof. Well, here it tells us the version that I'm using, and also things that I don't know why are being done. Why do you use the user's name with the host of the machine that I'm using to log in? Do you really need that? And then what happens if we chat? Well, this is the IM. So the chat is very clear. So I can see the username. They are communicating, they are engaged in dialogue. And the next thing I was interested in was, well, if there is a file exchange, can I rebuild the file? I think so, but I did not finish it on time to show it to you today. So I can see the control channel. I can see that Skype is telling me the type of file that I'm exchanging, when the exchange starts, when it finishes, how it went. However, so far, didn't do, I don't know how it did the disencrambling, but the file transfer was there, and now I want to reconstruct the file. The next thing was like, can I listen to voice conversation? I am also working on that. I can also see a clear conversation, okay, and of course it will require more work, okay, I have to continue working on that. Other than seeing easily the exchange that is taking place without the user being aware of that, another issue that was of concern to me was seeing the huge amount of things that Skype downloads in order to work, and from many different places. Many of them came from JavaScript. One of them called my extension significantly. It is not that I'm an expert on JavaScript at all. However, you can see that this comes from the chat at widget. So it's the widget that inserts ads on my chat window. And, well, this is an easy program. So it has this huge amount of lines of code for JavaScript. So it takes months to analyze all that. Well, if any JavaScript expert is interested in devoting a number of weekends to analyzing that, please let me know. Oh, I've been fast in my presentation. Conclusions. I am disappointed. I'm not longer enticed. You know, everything that was good, proprietary, encryption, supernodes, as everything in life. You know, when you grow up, things get worse. Well, proprietary encryption has been replaced by SSL. Uses certificates of the operating system in silence, so to speak. So you can do man in the middle of SSL. The only thing you have to do is to insert a private SSL as a reliable one within the OS. And then, because it downloads many data and you can do man in the middle, I would be very much surprised if you couldn't hide within those scripts a JavaScript code that will do things that we wanted it to do by using the permits that Skype uses to execute itself. Well, I've been really fast, eh? And this is all from me. Thank you so much. If you have questions, we're very happy to take them.
Hola Alberto, ¿qué tal?
Hola.
Hello, Alberto. So the Skype client, was that the Windows client? Well, both, Windows as well as Mac OS. Without inserting a CA, what was the result? Before you inserted a CA, what was the result? Well, Skype does not log in, does not log on. You know, it just stays login, never connects.
Viendo esto, el tema de protección de datos.
Well, data protection issue.
La legislación española
well, is it that the Spanish legislation and European legislation is being breached for this, in this application? Are you referring to Skype? Oh, yes, of course. Clearly, Skype is breaching the legislation. Is there any measure in that regard? Are they taking any measures in that regard? Well, I'm sure Germany and any other countries, well, have also follow European legislation. Are they taking any measures in order to prevent or, well, to stop sending out information without having the permit or consent of the user? Look, I have no clue whatsoever about laws. I'm very happy, far from laws. You know, if you are into laws and you don't have a good lawyers, you are very likely to have big problem. I just don't know. I wish they are taking some measures in that regards, but I cannot really answer. Sorry. Well, I have a question. Did you study the certificates? Who signs them? What are their characteristics? Do each application have a different certificates? Well, I didn't do that matching, but from the names, you could see some matching or some kind of correspondence. However, others were more general. I didn't do any correlation. And who signs the certificates? Well, some were signed by Entrust, others were signed by Baltimore, whatever. So I didn't follow the chain. I didn't do that correlation. Thank you. Highly interesting talk. So you mentioned that there is a version, an early version and a posterior version where the we have different behavior. Would you tell us more about that? And then, are there any alternative to Skype? And if not, is there a possibility to create it? Well, earlier versions to 6.11, if I try to do SSL interception, even no, I don't get any interception. I cannot really intercept anything. So that is to say, I do not really see anything different in my analytics system than before, when I didn't do an interception. Well, it doesn't show up anything, right, or anything different. So to me, Skype was unique. Huh? I just don't know. I'm not aware of every single application that could do that, and I was not obsessed about Google Talk or Hangout or any other. I was obsessed by this one. I had an actual paranoia. Well, I have many paranoias. This is one of them.
Hola.
Congratulations for your work. So, authentication process associated to users, which one has been the most interesting one when you access the user number and the password? Did you do further analysis or more in-depth analysis? What is most interesting for doing exploding or thefting or theft identity? Any challenges? Well, authentication. Well, the previous steps to presenting to what I believe what it is, the user identity code. I gave it this number. I name it yourself. I don't know. Perhaps the name is Universal Incorporated. I don't know. I guess that is it. But I don't really know whether there is a previous challenge or not. But systematically, in the same points, there is always a presentation for the first time of the UIC together with the user's number. I tried to do reverse engineering from that UIC because I knew the password. So I tried different hashing systems to reproduce that chain. However, when you do that kind of blindly, by trial and error, you are using lots of resources and the success rate is low. So at this point in time, success rate is low. Hello. So you say that the previous version, the early version, you were passionate about it because you knew nothing about it. Now that you can have that information, you can know more. Once you passionate it anymore, because now you know what Microsoft is doing. Why don't you like it anymore? Well, because I don't like my findings. Would you say that ignorance brings happiness? Or lack of knowledge brings happiness? Well, I never thought it that way. What I thought was the following. So if I use proprietary encryption mechanism, the possibility is not only for Microsoft, but, well, I am more concerned, perhaps I am mistaken, but my biggest concern, it was much more difficult for me from the technical viewpoint to access this information. So it is not that I lived in ignorance. Microsoft, June 2011, bought Skype. Yes, Microsoft bought Skype in May, and then in June released the patent for a legal interception system to intercept IP, voice over IP communications. I was concerned about the rest, all the others, and I say, what happens with privacy? So that you can see that communication takes place with many other places or sites that I am not fully trust, such as, I don't know, ads networks and analytics networks. So my idea is, if this is closed, it is less likely to have these intermediate type of things. So those Facebook connections, are they reflected on Skype? When you log on, Skype says, oh, I'm going to log on to Facebook and this and that. Does it tell you so? Well, perhaps it's me who doesn't know how to find that information. Yes, I was really surprised when I found out. I was not surprised when I found out ads, because there was a little thing over there changing all the time. I was surprised by finding analytics. What is the type of information that it gathers? Whom I call, how often do I call that person? Thank you.